All right, applied recalc. Just like with the other parts, we're starting with the exact same information that we had before. So I know that 12x plus 24y equals 780, and I know that x equals y plus 20. We're gonna look at a different method, not substitution and not graphing, to get to the exact same solution. And this is called elimination. We're gonna try to get rid of one of our variables by adding or subtracting both equations together. So to solve this kind of problem, I've just rewritten my equations. The red one I haven't changed at all. The blue one, I've just moved my x to the other side by subtracting it from both sides of the equation. The reason I've done that is I want it to look like my other equation. I could have changed the red one around, it doesn't really matter as long as they look similar. And now what I'm going to do is something a little bit different that you haven't seen before. I'm going to either add an entire equation or subtract an entire equation. In this case, I've chosen to add the entire equation. So 12x plus negative x, we're going to solve what that number is going to be. Then we're going to do positive 24y plus positive y. We'll write down what number that is. Plus 20, because we have nothing from the red equation. And then our equal sign still drops down. 780 plus 0 gives us a number at the end of that. So let's see what that looks like. And unfortunately, it kind of makes a mess. It gets close to general form, actually, which is kind of interesting. But I can't really, I don't know how to solve. Like, I don't know how many buses I have with that information. It's just a bigger equation. There's more numbers, there's larger numbers in it. It's a little bit more difficult to work with. So that didn't really help. There must have been something else that we have to do for elimination. And as it turns out, there is. So I've removed the solution to our previous problem. We're going to change the blue equation a little bit more. We have to eliminate one of our variables, either x or y. And it doesn't matter which one you choose. Usually the equation will be set up so that one of them makes a bit more sense than the other, but it really doesn't matter, you get the same solution either way. In this case, because my x value is already negative, I'm already subtracting x values, I feel like it would make more sense to get rid of my x values as opposed to the y values. So that's what I'm going to do. If you want to get rid of the y values, you can do that as well, but that'll be a subtraction problem instead. Instead of adding just one negative x, I need to get rid of 12 of them. So that means I'm going to have to multiply my x value by 12. But notice how I'm working with an entire equation. So that means I have to multiply my entire equation by 12 first. So this is what the math of an elimination problem looks like. The red equation in this case stays the same. The blue equation is multiplied by positive 12. So I'm adding 12 times my blue equation. Looks a lot more complicated than substitution, and it kind of does feel like that, but we get a much nicer solution doing it this way. So I'm going to multiply that 12 into the blue equation, and then we'll do the math with that. Okay, so now that I've multiplied that 12 into my equation, I have negative 12x plus 12y plus 240, and 12 times 0 is 0. And now I can actually add my blue equation to my red equation. So 12x plus negative 12x, well, the 12x's, they all cancel each other out. I have 24y plus 12y, I end up getting 36y. And I have 240 by itself, so it just adds to nothing, I still have 240. Lastly, I have 780 plus 0, which equals 780. And if you watch a substitution video, we've seen this equation before, right? The math, now we do a bit of algebra to solve for y. Y ends up equaling 540 divided by 36, which means that y equals 15, the same answer we got in the last two solutions as well. We can use the same logic that we used in substitution to solve for our x value, so x must equal y plus 20. 15 plus 20 is equal to 35. So we have 15 small buses, we have 15 large buses and 35 small ones. Same solution for all three methods. Which one you choose to use depends on your personal preference. You do need to know how to do all three methods, so it's a good idea to practice all of them. I'm going to give you some practice for elimination here. We'll look at elimination part 2 a little bit later on, where it gets a little bit trickier, but it's not so bad. So make sure you're practicing all three methods. Make sure you have all three methods in your repertoire when you're solving one of these types of problems. Because sometimes elimination is better to use than substitution. Sometimes substitution is better. Graphing is almost always the best option. It's just sometimes you won't have access to using a graph. So Just be aware of that.